everybody. We got another video here. We are learning to solve absolute value inequalities here. So just a little bit of a step up from last time where we did absolute value equations. Now we're doing inequalities. Okay, so I'm going to introduce it to you here, and then we're just going to walk through a few examples, just like normal. Hopefully you would have seen the video already at this point where we reviewed inequalities, and there's that one rule with inequalities that's different from equations, right? So if I just solve this top one here, right, if I want to get the x by itself, I would add 5 to both sides, and then I'd be left with negative 2x is greater than 16, and then I would divide by that negative 2, okay? But when I do that, right, I'm dividing both sides by a negative. So because I'm dividing by a negative number on both sides, what happens is that inequality sign flips. Okay, that's going to become, and it was greater than here, now it is less than. Okay, so my answer would be x is less than 16 divided by 2, which is negative 8. Okay, so this answer would be x is less than negative 8. But if I have an absolute value now, what does that mean? So remember, with absolute value equations, right, what we have to do is get the absolute value by itself on that one side, okay? And then once the absolute value is by itself, we split that, right? We split that into two separate equations, or it's going to be inequalities here, okay? But it's kind of combining my rules. When I have an inequality here with an absolute value, I'm going to combine my rule of flipping the sign around when I divide by a negative, right? Change it to a negative, and then splitting it. Okay, so watch this. So my two separate inequalities I'm going to have here are, right, just basically dropping off the inequality sign, and it's negative 2x minus 5 is greater than 11. Just exactly what it was, just without the absolute value bars. Okay, so that is one inequality that I'm going to solve, and I actually already solved that, so I know that that solution is going to be x is less than negative 8, right? Because that's the same exact one as this one up here. But my second one, watch this, okay? I drop off my absolute value bars, so it's negative 2x minus 5, okay? But for this second inequality, okay, right, in the equation part, this is where it's negative 11, right? I make it the negative version of this, okay? But I also flip my inequality sign, okay? So I'm kind of doing a double flip here. I'm flipping my inequality sign, and I'm flipping this positive answer to a negative, okay? And again, I do that, it's the same reason as I would divide by, right, when I multiply or divide by a negative here, that flips that sign, and it's for the same reason that I have to flip this inequality sign when I change this solution to a negative, okay? So just remember that there's when we flip the inequality sign when we also flip the answer. Now I can solve this for x, so I plus 5 to both sides, and I get negative 2x is less than negative 11 plus 5 is negative 6, okay? But watch this. When I divide by this negative 2, the same rule still applies here as well. This is negative 2. I'm dividing that from both sides. So I actually flip it back, okay? So x is greater than positive 3 would be the solution for this one, okay? But just like absolute value equations, like in the last video, I have two different solutions, okay, for my two different equations or inequalities when I split them up, okay? But the big thing that you're going to have to worry about here is flipping these signs around, okay? Okay, so I have my second example here, the absolute value of 3 minus 2x minus 4 equals, or is less than or equal to 1, okay? And so I look at this, again, I see the absolute value signs, I see that it's an inequality, okay? So there is going to be some splitting up going on and changing around this answer, okay? But first, before I split anything up, I have to cancel out anything on that one side that's not part of the absolute value, okay? Just like with equations, okay? I have to do that same thing. So I would add that 4 to both sides, and I would get absolute value of 3 minus 2x is less than or equal to 1 plus 4 is 5, okay? So I isolate that absolute value first, okay, until that it is the only thing that's over there on that one side, okay? And now I split it up, okay? I split it up into two separate inequalities, okay? And again, the first one is going to be the exact same as it shows, just without the absolute value bars. So it's going to be 3 minus 2x is less than or equal to 5. Okay, that's how my first one is. And then I just solve that out for x like normal. Okay, but my second one, again, this is where the double flip happens. So it's going to be the same thing here on the left, just without the absolute value bars. So 3 minus 2x, and then double flip. I flip around the inequality sign to greater than or equal to, and then I change this positive 5 to a negative 5. Okay, so flip the inequality sign, flip this from positive to negative. Okay, now I have two separate inequalities, so I'm going to get two separate answers, and I solve these out. Okay, so I'll go a little bit quicker. Minus 3 from both sides, so negative 2x is less than or equal to 5 minus 3 is 2. But again, you have to be on the lookout too for when you within these two separate equations, when you divide by a negative, that flips the sign again. Okay, so sometimes we see that, and we do here. Okay, so we divide by this negative 2, and again that flips this sign, so it is x is greater than or equal to 2 divided by negative 2 is negative 1. So x is greater than or equal to negative 1. And then for this one, same thing. I get the x by itself, so I minus 3 from both sides. Negative 2x is greater than or equal to negative 8. Okay, then I divide by negative 2. Now I get x. Again, I divided by negative, so that flips this inequality sign from greater than or equal to less than or equal to. Negative 8 divided by negative 2 is positive 4. So those are my two different solutions. X is greater than or equal to negative 1, and x is less than or equal to 4. Okay. Now notice in the directions it says solve the inequality, which we did. I found my two solutions. And then it says graph the solution on a number line. Okay. Now let me erase some of this so we can get the number line up here. So I have my number line here, and what I'm going to do is graph these, okay, on a number line. And I'm going to graph them one at a time, but I'm going to graph them on this, both on the same number line here, okay? And so what is that going to look like? Well, I think about x is greater than or equal to negative 1, okay? Hopefully you remember from the video for just solving inequalities that x is greater than or equal to negative 1. That's a closed circle, right? Because negative 1 is included in that, right? X could be exactly negative 1, okay? And then all the numbers that are, x could be all the numbers higher than negative 1 as well. And so that, and again, I said in the other video too, that because this is an arrow pointing to the right, that's where this goes, okay, like that, okay. But there's a second kind of bound, or there's a second kind of stipulation for what x could be, okay. It says x is also less than or equal to 4, positive 4, okay. And so what does that mean? Well, if x is greater than or equal to negative 1 and less than or equal to 4, okay, less than or equal to 4, I'm actually going to erase this because that's not going to be true. 4, right, it would be a closed circle here at 4, and it would be pointing to all the values less than that, okay? So there's kind of these two, that's the thing with these absolute value inequalities. It kind of is going to give a span of numbers, okay, that x could be. So this one is saying x could be anything greater than or equal to negative 1, but also less than or equal to 4. So basically anything between these, okay, x could be, okay, but nothing else outside of that, nothing less than negative 1 or greater than 4. All right, so let me do a few more examples and hopefully it'll make a little bit more sense. All right, so we've got number 2 here, and it says solve the inequality and graph the solution on a number line, same directions. Okay, so I look at this. It's got 3 times the absolute value, 3x minus 6, is greater than 45. Okay, and just one thing, one misconception kids often try to do. Some kids try to distribute this, okay? But again, you can't, I said it in the last video, you can't touch what's in the absolute value, okay? This isn't the same as just parentheses, okay? So you can't do that, okay? You cannot distribute. What's inside the absolute value is kind of untouchable. until we split it up. Our first step here, right, this 3 is not part of the absolute value, so I have to cancel it, which is, right, this being multiplied right now, so I have to divide it, okay, divide 3 from both sides. I do that, and I'm left with absolute value 3x minus 6 is greater than 45 divided by 3 is 15, okay, and now that the absolute value is by itself, right, I split it up, all right. So I keep it the exact same, just without the absolute value bars. So 3x minus 6 is greater than 15, okay? And then the second inequality, again, double flip. Flip the inequality sign, flip the answer. So 3x minus 6 is less than negative 15, okay? Double flip for that second one. All right, now I solve these. Again, hopefully the solving part isn't too bad for you. So you add 6 to both sides, and you get 3x is greater than 21. You divide by 3, so it says x is greater than 7. Okay, and then you do this one, right? Same thing, you add 6 to both sides, so you get 3x is less than negative 15 plus 6 is negative 9. Then you divide by 3, so x is less than negative 3. Okay, now I got my two solutions. So x is greater than 7 and x is less than negative 3. Okay, now let me graph these for you, and you're going to see it's going to be a little bit different than this one, okay, for a couple reasons. X is greater than 7. So think about what that means. I go to 7 on my number line, okay. I draw a open circle, okay, because 7, it doesn't say greater than or equal to 7, right? It's just greater than 7. So it can't be 7, but it can be anything higher than that. So this arrow would actually be going to the right. So it could be 7.01, 7.5, 8, 10, 20, and so on. And then the second one says x is less than negative 3. Okay, so I go to negative 3, and I draw another open circle there, because it doesn't say less than or equal to. But then I draw that arrow, it's saying less than negative 3. So that would be all the numbers below that. So that would be going this way. So this is a situation where we do have spans of numbers, but the arrows are going the other way. And that happens, okay? So it's saying x could be anything higher than 7, or x could be anything lower than negative 3. So there's just a little bit on solving absolute value inequalities. I'm going to go over a little bit more in another video just because there is a little bit more to cover with these, specifically with the solutions. But that's all for now. Good job.